Hi, today we are going to look at the chain rule with a small wrench thrown into it. We're going to look and see what happens when we throw some product rule and quotient rule in with it. And actually, just for fun, we'll also throw in some sum and difference rules too, which doesn't make a whole hill of beans worth of difference, but it is a minuscule wrench, if you will. Okay, so let's start by looking at that. So let's say in our first example, we'll do y equals x cubed plus 2x squared plus 4 all to the fourth. So this has two terms, right? We've got our x cubed and our 2x squared plus 4 to the fourth, and those are two separate terms. So sum rule tells us we're going to take those derivatives independently of each other. So to do that, we're going to take that first term, x cubed, and it's going to be 3x squared. We're going to add to that the derivative of the second term, except the second term is going to need chain rule with it. So we're going to use chain for this. So we're going to take the derivative of the outside, which is something to the fourth, and then the derivative of the inside, which is 2x squared plus 4. So the derivative of something to the fourth is 4 something cubed. We're going to multiply that by the derivative of something, which happens to be the derivative of 2x squared plus 4 is 4x. Now we can clean this up a bit. This 4 is just being multiplied with this 4x. So let's clean that up, and we'll get y prime equals 3x squared plus 16x times 2x squared plus 4 cubed. We cannot distribute this in or multiply this together because of this exponent. Don't let that get you. Okay, so now let's take a look at what this is going to look like when we throw product rule or chain rule into it. So here's my first example. X times the square root of x squared plus 1. Now, if you want to hit pause and see if you can do this, have at it. If not, let's keep going. So here we've got our f of x is at x, and then this whole radical is going to be our g of x. So we're going to use product law. But before we get started on this, we're going to turn this into exponent form. And I'm just going to throw some brackets in here so it becomes really obvious where my f of x and my g of x are. That radical becomes an exponent of half. So now it's really clear that we need product law, and it's clear that we're going to need chain rule because we've got something in the middle that has a derivative plus something to the 1/2 has its own derivative as well. So product law tells us that the derivative is going to be, the derivative f of x is going to be g f f g. So we're going to take g of x times the derivative of f of x plus f of x times the derivative of g of x. So here we go. G is x squared plus 1 to the 1/2 times the derivative of f. Well, the derivative of x is just 1. So I'm going to write that in so I don't get myself mixed up. Times plus f of x, which is x, times the derivative of g of x. Well, that's going to be chain rule. So I'm going to throw in some square brackets here so I don't get messed up. So I've got 1/2 times x squared plus 1 to the negative 1/2 because I took my exponent and subtracted 1 times the derivative of the inside. Well, the derivative of x squared plus 1 is just 2x. Okay, so there's my unsimplified version. We're going to clean this up. In this first term, I'm going to put this whole thing in a radical. So that's going to give me the square root of x squared plus 1. Multiplying by the 1, of course, does nothing. Plus, over here, I don't really need these square brackets, as it turns out. I can make them go away, and I can just kind of put brackets around that 1/2, right? So I'm going to multiply my x times my half times my 2x. And then if I look really closely at this, well, let's just start there. How about that? So that's going to give me 2 times a half is 1, and x times x is x squared. So x squared. Now, this piece, this x squared plus 1 to the negative 1/2 means it needs to go to the denominator, and it's going to be in a radical. So I'm going to go ahead and leave my x squared on top. I'm going to drop the rest of it to the bottom. And there is my final answer. That's how I use chain rule within product. All right, now chain with quotient is the exact same situation. We're going to just keep following your rules and procedures. Those don't change. They just kind of combine together. So let's take a look at this. So if we have y equals x squared minus 1 cubed over x squared plus 1. So this is going to be my f of x in the numerator, and this is going to be my g of x in the denominator. And remember that quotient law says the derivative of f prime is going to be our gf of g again, but we subtract and we divide by g squared. So we're going to follow that. So y prime is going to be g of x, which is just x squared plus 1, times the derivative of f. Well, we're going to need chain rule, so I'm going to bring that 3 to the front. So 3 x squared minus 1 doesn't get changed yet, but it's now going to be squared. And then we're going to multiply by the derivative of the inside, which is going to be 2x, minus f. X squared minus 1 is f of x, times the derivative of g. The derivative of g here, g of x does not need chain rule. It's just 2x. All divided by g of x squared, so that's x squared plus 1 squared. This is a hot mess, so we're going to clean it up. So let's look over here at this chunk first. I can't do anything to this because it's being squared, unless, of course, I want to multiply it out. But with an exponent, we can't touch it. However, x squared plus 1 times 3 times 2x, I can do something there. 2x times 3 is 6x, and if I multiply that in, then I'll get 6x cubed plus 6x. And then my x squared minus 1 squared is still there. Over here, I'm just going to move this 2x to the front. I cannot multiply it in because of the cubed. And in the bottom, I've got x squared plus 1 squared. We can simplify it more, but in this type of problem, it's probably not an efficient way to go about it. Okay, there you go. Ta-da!